This video is going to continue to look at the unit circle just like the previous video, but this time we're going to look at an angle dealing with a 60-degree angle instead of a 45-degree angle. So to start off, I want to go back to looking at our right triangle and see if we can recall some information here. If we have a 60-degree angle here, and this is 90-degree, then of course all three angles add up to 180, so therefore this angle must be 30 degrees. And this is something you may recall, that if you have a 30, 60, 90, this is a special right triangle where the side opposite of the 30-degree angle, if that is x, then the hypotenuse, the side opposite of the right angle, is twice as big as the smaller side. Well, the smaller angle is 30, so the smallest side is x. So if we know that the side of this opposite of the 30, if we know that side is, I'll just make up a number, if this is 4, then that means the hypotenuse must be 2 times 4, so that means this side must be 8. And then for the side opposite of the 60-degree angle, that would be x multiplied by the square root of 3. So what that would mean is if x is equal to 4, then that means this side would be 4 times the square root of 3. So we have x for the short side opposite of the 30. 2x is the length of the hypotenuse, and then opposite of 60 would be x times the square root of 3. So this is probably some reference of what you covered maybe in Algebra 2 or a geometry class. So I mentioned that because we want to apply some of that to our next example when we look at this 60-degree angle. So if we look at our circle, we have the 60-degree angle in here. So we know if it's 60 degrees, that's going to roughly be right about here. And we're going to bring down this side to form our right angle. Now, just as we stated before, we know that if this is 60, this little angle up here must be 30 degrees. And our goal is to find out what must be the x-coordinate for this point. Well, this is going to go back to using this idea of this triangle here. And let me maybe redraw this so we can see this as a visual. If this is 60 and this side is 30, this is x, this is twice as big, and this is x times the square root of 3. So over here, we already know that the hypotenuse is 1 because, again, this is the unit circle because we're going out 1 unit. So the question becomes, what is the x and y coordinate for this particular point? Well, if we know that the hypotenuse is 1, okay, then can we determine what this side is at the bottom? Well, over here, if this is x, this is 2x, so that means down here, if we know the hypotenuse, this side here must be half that, right? So 2x divided by 2 would be x. So therefore, we know the value here would be half of 1, so that means this distance must be 1/2. So that's going to tell us the x-coordinate is 1/2. So then how do we determine the other side? Well, based on this statement, it's x times the square root of 3. Well, if our x is 1/2, then that means this side must be 1/2 multiplied by the square root of 3. And of course, the other option is we can always use the Pythagorean theorem to find this missing third side. We could always do 1/2 squared plus y squared equals 1 squared, and we can solve for y. But since we have this shortcut over here, we know it's just going to be 1/2 multiplied by the square root of 3. Or another way to write that would be the square root of 3 over 2. So that's going to give us the location, the coordinates rather, for this 60-degree angle on the unit circle. Now, the 60 degrees, this would be the same angle as pi over 3. So again, I want to kind of work with radians as well. So if we were to mark off our angles here as pi over 3, then over here we would have our other triangle, which would be at 2 pi over 3. And then we could go down here to the bottom and we would have 4 pi over 3. And then over here we would have 6 pi over 3. And again, we want to be able to determine what are the coordinates for each of these points. Well, if we were to draw in the triangle once more for each one of these, well, one thing if you haven't noticed already, the x and y values are still going to be the same because we're still going to go over a half. The only difference now is our half is in the negative direction, so it's a negative 1/2, and the y coordinate still going to be a positive square root of 3 over 2. And then when we move down here to the third quadrant, we know that any point in the third quadrant, both values have to be negative, so that means we have a negative 1/2 and a negative square root of 3 over 2. And then similar over here in the fourth quadrant, our x coordinate has to be positive, and then our y coordinate would be a negative square root of 3 over 2. And of course, if you want to check this, you can always take any of these points and you could plug that into the Pythagorean theorem. You could always look at x squared plus y squared equals r squared. And for this unit circle, the r squared here would be 1 squared. So that means the x squared plus y squared has to be equal to 1. And each one of these, if you were to square 1/2 and if you were to square the square root of 3 over 2, you're going to add those together and you would certainly end up with 1. So just like the previous video with the 45-degree angle or the pi over 4, here we went through how we could calculate the actual coordinates, the point on the unit circle where you have pi over 3, 2 pi over 3, 4 pi over 3, 6 pi over 3, or in other words, you could think of this as a 60-degree angle or a 120 degree, and so on.